Hello students, this is our first video in this group. We will be looking at the homework questions and the commonly made mistakes, and then we'll be coming back to this, how to cheat. But first, the good way. But first of all, let's start the homework. Alright, this video is designed for people who don't know anything at all about logs or how to do the homework. So by the end of it, you should know both perfectly. Okay, what is a log? A log of a particular base of a number is asking the base to what power gives the number. Okay, so if you look in your calculator, if you type in your calculator log 10, you should get 1. Because the calculator inherently uses base 10. So you're asking the calculator 10 to which number gives 10, which is 100. Log of 100, sorry, is 1. Log of 100 is 2 because you're asking the calculator 10 to what number gives 100. So that's 2. Therefore, log of 1000 is 3 because 10 cubed is 3, and so on. The calculator naturally uses log to the base 10. If you use that log, you don't have to write the 10 by the log. However, if you use any other base, it is mandatory that you have to write the base. For instance, log of base 8 of 8 is 1. Good. Then you can also say this. Log of the base 2.71828 of 2.71828 is 1. Obviously, the same base, same number, 1. Now, 2.7182 is a special base, and log to that base is called the natural log, which we, sorry, the focus, which we call ln or ln. 2.718 is a special number called Euler's number, and it is denoted by a common e. Like we know 3.142 is pi, this is e. So we can say ln e is equal to 1. Now, when we have log problems, what the teacher would ask you is she will give an equation and say, express this equation without logs. Doesn't mean without using the log rules. It means that write back the equation, but she mustn't see the word log inside of it. And we use mainly, but for this homework, just these 5 rules. There's also a change of base rule we didn't use, but we'll do that another time. So basically, what we do is we have, this is example number 1. What we try to do is reduce this side that has 3 logs to just 1 log, anti-log both sides, and then get the answer. We do reduction using these rules. So you can turn 2 logs into 1 by using this rule. We're adding, just multiply the number that is being logged. Okay. So we want to get whatever they give us into this form first by using mainly these 3 rules. If we have something like 2 log q, we want it to look something like this, a log with a number at the back of it. So we can turn 2 log q, which is in this form, into this form. The n to the log is equal to log a to the n. So this looks like this more than this does, right? Because log to something. So, and if you have a number, you just turn a number into log 10. So if we have 4, we express 4 as 4 multiplied by 1, or 4 log 10. Alright, so the first step is to produce everything in log form, looking like this, and then we'll do reduction, and it is very simple. So let's go. Number 1. The writing in blue shows the common mistakes made by students, and the black is the correct writing, the correct working. So let's go. So first question, the most common mistake at the beginning is to use this and then put this bracket here. Now I thought this was this at first also, make this one term, but then I realized that if the question had meant that, they would have put the bracket. So if you don't see a bracket, do not put a bracket. Please treat the number 3 as a separate entity. Right, so this is the first wrong step in blue. So let's continue with the right steps. So we'd use this rule to turn We use this rule to turn 2 log q into log q squared, and we continue. So log p is equal to this turns to this. This comes down, and 3 is represented as 3 times 1, which is minus 3 log 10. So, and then I use the same rule. 3 log 10 is equal to 10 log to the third power. Just throw this up there. Okay, next we use the sum rule. This plus this could be combined into multiplication, which is this rule. Answer. Tell them I'm busy. Minus log k minus log 10 to the third power. Now we have the next common mistake, which I explained in previous videos. We cannot maintain the minus sign here and then say this divided by this. This is a mistake. The reason why is because if we do this, let me explain. If we do that, let me just show you. If at this stage, we go from here and maintain the minus, well, look from here to here, right? We go from here, we maintain the subtraction sign, and we say k divided by log 10 to the third power. We're basically saying that this is the same as this, because we just take one step and then we say, okay, this divided by this, and we maintain the minus. But if you say this is equal to this, it is an error, because if you expand this, you will get minus log k plus log 10 to the third power. And this is not what the question is actually saying. It's saying minus log 10 to the third power. So going from this step to this step is saying that this is the same as this, but it is not, because this is this and this is not this. Okay. So what is the correct thing to do? I would say don't ever touch a subtraction sign unless it is being subtracted from a positive number. That's the only time you can manipulate the subtraction sign. What is being subtracted from a positive number? Of course, there's not a strict rule, but to avoid mistakes. So you can go from here to here. You can say this divided by this, because we've been subtracted from a positive number. Alright, so we have a log of pq squared divided by k, and we bring down this. So once again, we have it being subtracted from a positive number, so we can work a next division. Now, when you're dividing, the best thing to do is to just say multiply by 1 over the number you're dividing by. Instead of say divide by 3, say multiply by 1/3. Don't divide by 5, multiply by 1/5. You're less likely to make a mistake in this when you think of it like that. So we have pq squared over k multiplied by 1 over 10 to the third power, which is this, and that is our correct answer. And that's number 1. Alright. There is an alternative way you can do this. What we can do is, every time you see a negative sign, turn every single thing to the right of the negative sign into one term. Meaning, when you see this stage, right? When you see this stage, you can maintain this minus sign, and you put your brackets and change it accordingly. So if you put the brackets here, this will be the same as that. Right, because expanding this minus it gives you back this. There's nothing wrong with doing this. So when you turn everything to the right of the minus subtraction sign into one term, you can simply say this divided by all of this, and then work out this relationship. So we have pq squared all over this relationship, this multiplied by this, and it's the same thing. And that is the alternative way. Okay, question 2. Okay, so this one is simple. We start with this. Oh, I did not say anti-log both sides, but you get a point. You'll see in the rest of the questions. So What did we do? We turned 1 into log 10, this into log m to the third power, this is the same rule, log s cubed, and we just use the multiplication rule twice, and we get our answer. And that is as simple as that, number 2. Okay, number 3. Okay, we have ln. Now, note, we cannot turn 2 into uh, 2 log 10 because we're not dealing with log to the base 10, we're doing log to the base 2.71828, which is log to the base e, which is ln. So you will have to express this as lne and not log 10. Right? You express it as this and not that. Alright, so 2 is 2 lne. So we use the regular log rules because ln is a log. Alright, so we throw up the half, this is, we throw up the 3, and this. We repeat the same rules for this part, and once again we have a next very common error, adding this to this. Uh, First of all, I said, do not ever touch or trouble. If you're scared you might make a mistake. Don't ever trouble a negative log unless it is being subtracted from a positive log. Like the positive log is on the left hand side and negative log is there. Then you can manipulate it. Don't otherwise just leave the negatives alone. Just leave negative people in the corner. Just leave this. Because why you can't do this is because when you turn this into this, you're actually adding this to this, and this is not really an addition because if you have negative 3 plus 5, you're basically subtracting 5, subtracting 3 from the 5. So if you relate this to this, it'd have to be some sort of division since something's getting less in magnitude of subtraction, so it's the divisive relationship. So from here to here, divisive, I don't think that was right. Anyway, from here to here is wrong. What you could do is use the rule when I say if you have, I will show you if you have a minus sign, you can make everything to the right of the minus sign one term. So I factorize this out. This is the same as that. That is the same as that. So I do this minus all of this. So I have this q plus 1 to the half all over, and then I do this relationship, which is r cubed divided by e squared, or r cubed multiplied 1 over e squared, which is this. And this gives this when divided by a fraction, you upturn, and then we have simply, I'm sorry, this is bad video. And then simply we have this answer. Okay. I think I have an alternative. Okay. The alternative way is how I think people should do it without trying to do any hocus pocus, which is simply when you reach this stage with a minus, just rearrange the sum and put the positives together and negatives at the end. You can make that as a rule for yourself. Positives together and negatives at the end. And then the rules become simple and basic. You can safely multiply these two logs that are adding to form this, and then do your division, and you get the same answer. Alright? Oh, and our last step, of course, is to do the antilling of both sides, and we just get p is equal to that. I didn't show the last step for any of the previous problems. Okay, section 4. Sorry, question 4. Okay, what we have here, please notice a log is not in front here. So this 2, don't put a 2 right at the top here. Just distribute 2 with a regular multiplication. It will be there, and then use the rule. So this becomes log a squared plus log of the w squared, and use similar rule here, similar rule there, and we bring this down. The rule I like, as you might see, that whenever you see a negative, as I just said, just rearrange it and put all the pluses together and negative at the end. Or you can do this fancy thing, which is just to make everything to the right of a negative sign of the minus sign one term. So we turn this into this with factorization. And then we say this times this all over all of this, and then you relate this accordingly. Which is 32 multiplied by 1 over k squared multiplied by 1 over r squared multiplied by 1 over c, which gives this. And I'm showing you this, but it might be a little awkward to do it like this. What would be simpler if you just rearrange when you're at this stage? Just simply rearrange this sentence, sorry, this equation, and put a negative at the back, and that will be it. It's far simpler. Okay, the last question, and then we look at how to cheat. This just simply remove the brackets. I don't think I need to explain this. Uh, we have KL, which is not a log here. So we use the regular rule saying 3 is equal to 3 times 1. So KL is just KL times 1, which is KL ln E. Again, we choose ln because the rest was ln. We want everything to the same base. And from here, we just used all the regular log rules that we spoke of before. From here, I rearranged it and put all the pluses together, and then the minuses at the back. So this is not ink. This is ln. Well, this is lnk, right? So I put the pluses together, minus behind. This times this. This plus this is multiplication. I write back the two subtraction, and then I relate this to this with a subtraction. Leave this out, and then finally I put in the last subtractive relationship, which produces a division, which is 1 over e to the kl. And then finally we have this. Take the antilin of both sides, and you just get well, I is equal to that. And now the moment you guys have been waiting for, which is how to cheat. Alright, now we will try to work all these questions in 60 seconds. All 5 questions in 60 seconds. So let's see how we can do this. The rules are simple. I call it translation, right? Please don't do this officially in class, because you will not get marks for it. This is just to know what is the correct answer, and then work towards the correct answer. Right? So it's called translation. And what you simply do is remove the logs out of everything from the first step, and just re-express the equation in English as you know it. And we use three simple rules. Every positive number goes at the top of a fraction in the answer, and every negative number goes at the bottom is the second rule. And if you just have a digit expressed without logs, you use the base and put it to that power. Right? So we have 60 seconds to do 5 questions. That's 12 seconds a question. Let us see if you can produce all 5 answers using the translation rule in just 1 minute. Okay. So therefore, so let us practice one. Alright, let me just log of x is equal to log p. Just let me set it up. There's the first question, second question. I just want to set up the platform. Remember, we have 60 seconds to produce all 5 answers. Can we make it? The fourth question is 2. Oh, by the way, the background music playing in the background is a song called Background. Check it out. Lecrae featuring Andy Mineo. Okay. KR plus R. Okay, I didn't give myself more space here, but we have 60 seconds. This will be unedited, so if I fail, you will know. So, can you see this? Oh, can you see this? So my assistant would put the stopwatch where the camera can see it. All right. So let's go. No. So X R is equal to something. Okay. Finish. Oh, 49 seconds. It is a record. Wow, this looks like a total mess. Okay. I should have done this on the board. So let's look a little closer. Let me see if our answers are right. Every positive number you put at the top of the answer, and the negative you put at the bottom. It's as simple as that, and you just remove all the loss and you have the answer in one step. And it just takes 12 seconds to do each one. As I said, every number you use the base to that power. So the one that's called 10 to the first power is a positive one, so I leave it left to the top. This was positive, this was positive. S cube, and that was it. Same thing here. 2 I call e to the second power since e was the base. This is the negative, so I have to put it at the bottom. This is the correct answer. And same thing for this. And check it out. And finally this. This one, please be careful. Look at the brackets. Look at the contribution to the equation. This is a minus lnk, but this is an inner bracket, so actually a positive lnk. So the k needs to go at the top. This is negative, so that goes at the bottom. So you can try it for yourself and see if you can beat my record of 48 seconds. All 5 questions in. Okay, 49 seconds, my assistant says. So that was it. How to cheat? You can do all 5 of those hard log questions in just 49 seconds. Look at that. All right. No, anybody could do it. All right, good. So section 2, simplify. Oh, the cheating, the how to cheat stuff. Please, that only works. A lot of some rules. The only works when all the bases are the same. So you might have to change the base first before you apply that rule. And the translation thing, it's not in any textbook or on the internet. I just made that up. So if you don't use it in the exam, and if you get in trouble, please don't reference me. I'm not saying it is official. It is just something to check up what your answer is supposed to be. You're not supposed to work logs like that. I just discovered that one day while I was doing logs, that you can just go straight to the answer right away by translating everything. All right, good. Section 2. We have 5 more minutes for this entire video. Section 2. A lot of people have indices problems, and the main reason is because, I mean, simply, if you're dividing, as I said, don't divide anything by any number. If you have to divide by 3, multiply by 1/3. I know it sounds kind of simple, but do it and you won't make a mistake, because I'm seeing a lot of mistakes with simple division. I don't know. Um, I I guess what the problem is let me show. If someone has 1/3, if they want to divide it by 5, they would put this and then flip this and then say, okay, well, 1/3 divided by 5 is the same as 5/3, and this is wrong. No, if you have 1/3, if you follow the rule and I say don't ever divide by 5, multiply by 1/5, 1/3 divided by 5 is that, and then you actually have the right number. So that's what I mean when I said don't divide by a number, just multiply by 1 over the number, and you're far less likely to make a mistake. Okay, so you turn the square roots into the fraction. Don't divide right away. Half, and you turn this into 1/3, and then, well, this is simple arithmetic. I just make you guys look at it without explaining, and then you can move on. Every term is being multiplied by this here, and then you subtract this from this. So 7/6 minus 1/6 is 6/6, which is just 1. So you just have a 5/2 divided by minus 1, which is 1 is 2/2. So 5/2 minus 2/2 is 3/2. And C is 1, negative 1/3 minus negative 1/3, or negative 1/3 plus 1/3, which is 0. And C to the 0, anything to the 0 power is just 1. So the C turns 1, and we just have AB to the 3/2 power. This is our second question here. I'll just look at it. I'm going to explain. You guys can look at it carefully, pause the video, and see exactly what I did. And then you can post questions at the bottom. Okay. I think I have a question missing or something. Or anyway, so our section 3. When you have this problem, just log both sides of the equation and use the log rules. So you have log of a multiplication, needs to be expanded into an addition, right? Then no, you can't multiply the 6 by the 8. Why? Because 3 times 5 to the 3rd power is not the same, is not equal to 15 to the 3rd power. So you can't just, if you have something as a power, you can't just multiply this by this. This is the next common mistake. Please log it, and then express this as log 3 plus log of 5 cubed. Okay. Remember, the test will be based on these things, so please look at this video. I have just 1 minute remaining. I don't want to make it longer than half an hour, so you can just look at this picture, pause the video, look at it carefully. I just made x the subject of the formula, maintain the form, and that's it. That's my answer. This is question 2. Again, at any time, you just pause the video, look at 2 steps, and you ask questions. The final question is here. I'm going too fast. Pause, read, answer question. And this is our first half an hour video. I hope it covered everything. Remember, test is Friday based on logs, indices, and epsilon delta, which I did not cover, which I will cover in a later video. Good night.